Part 4, this is for questions 31 to 40. Question 31, chloroethane can be used to make sodium propanoate. So you have here chloroethane, then an intermediate Q, and then sodium propanoate. So sodium propanoate, how does it look like? This is CH3, CH2, then COO, Na. And then here you have chloroethane. So if you have chloroethane here and then an intermediate Q, now there is another carbon added. We can extend the carbon chain by adding a cyanide. So that means I can have CH3, CH2, then CN. You see? That means I can use potassium cyanide or sodium cyanide in presence of ethanol. Okay? And then we have this substitution reaction. Then after that, we can hydrolyze this using sodium what? Hydroxide. So I'm going to write something like this. Chloroethane goes to this when I put, let's say, potassium cyanide in ethanol. So that is a substitution what? Reaction. And then from here, I can hydrolyze this using what? Sodium hydroxide. Because the salt here is formed, but if we hydrolyze it using, let's say, dilute HCl, we get a carboxylic acid. So we shall get propanoic acid. But in this case, because of the presence of this sodium hydroxide, then you will form the what? The salt. So here I will put aqueous dilute sodium hydroxide. So I can say also maybe plus water, something like that. And then we have that. So they are saying intermediate Q is hydrolyzed with boiling aqueous sodium hydroxide. That is exactly what I've said, to give sodium propanoate. Which reagent would produce intermediate Q from chloroethane? That is potassium cyanide in what? In ethanol. So this is our answer, D. Then question 32. 4 different alcohols are treated with alkaline iodine. Which row is correct? Now the products. Now to treat an alcohol with alkaline iodine and then you get a positive test, the alcohol must have this group CH3, then CH, OH. It must have this group. Whatever comes here, you don't know. Okay? An R group. So what is going to happen is that this one is going to be oxidized to a ketone. Okay? You will have CH3, then CO here. Okay? Then that R there. So what is going to happen then in the next process, these hydrogens in the methyl group connected to this carbonyl, they are replaced with first the hydrogen, the iodine. So you have CH3. No, actually it will be CI3. CI3, then C, this one here. And then hydrolysis now takes place. So this one is broken down. You just remove this one here. Then you have CHI3. This is the triiodomethane, which is the yellow precipitate. Then what remains here, you are going to have, we call it an ion of, it's a carboxylate. Actually, we call it a carboxylate. So you will have R, then COO minus. So let's look at these ones here, the alcohols given, and we see which one has gotten the CH3, CHOH group. Butan 2O. Butan 2O is CH3, COH. There is an H. There is a CH2, and then a CH3. This one gives, okay? That one can give a positive precipitate. So I just need to do away with those that do not do. So you have CH3, C, then OH, H, CH2, CH3. So this one will give a positive test with alkaline iodine because of this methyl group connected to the carbon holding the OH. Okay. How about propan 1O? This is CH3, CH2, CH2, OH. Now, this one is an ethyl group connected to the carbon holding the OH, so it will not give a positive test. Okay, so we remove option B from our answers. So this one will be off. Then propan 2O, you have CH3, C, then O, then CH3. This methyl group connected to this carbon. No. This is, pardon me here, this is an alcohol. It's not a ketone. So I have H here. So this one has the group, you can see it. Whether you pass this way or you also pass this way. So this one will also give, okay? So I'm here and here. Then butan 2O is CH3, C. And then we have an OH up here. Then H. And then CH2, CH3. Even this one will give because the group is there. Now the formula of the compounds. This one here is going to have, when you cut this one off, the carboxylate here is going to be a propanoate, CH3, CH2, COOH, but here they gave us an ethanoate. So that means now this one will be off, okay? It will be off. We go to the next one here, propan 1O. Propan 1O, remember this one we crossed it out because of this, so just forget about it. And then we come to C, put off this one here. The carboxylate is going to be CH3, then COOH, okay, which is here, it is okay. And then triiodomethane, it is this one, even that one is okay. So that implies that our answer is C, but let's check D. When I take off this one here, the carboxylate is going to be CH3, CH2, COOH, which is okay here. But then the formula of triiodomethane is this one here, but they gave this one here, which is completely what? Wrong. So that's why our answer is C. Question 33. The relative molecular mass of compound X is 88. Compound X is heated under reflux with an excess of acidified potassium dichromate 6 to produce compound Y. Compound Y reacts with compound X under suitable conditions to produce compound Z. The relative molecular mass of compound Z is 172, and they are telling us to find what compound X is. Now, first look at this one here. This one is CH3, CH2, C, then we have an OH here, and then a hydrogen. Then what else do we have? We have a CH2, then a CH3. When you oxidize this one here, you are going to have a ketone, CH3, CH2, then C double bond O here, then CH2, CH3. So this could be compound X. No. They said compound X is heated under reflux with an excess of acidified potassium permanganate to produce Y. So this can be Y, and then this is what? X. Then they are saying compound Y, this one here, reacts with compound X. Now, this is a ketone. A ketone does not react with an alcohol. Okay? So that implies that answer A is off. How about B? B is CH3. Then C, there is CH3 here. Then there is an OH. Then there is a CH2. And then a CH3. Now, this one is a tertiary alcohol. It cannot be oxidized. Okay? It cannot undergo oxidation. So this one is already off also, because of no oxidation that can take place. Okay? Then we go to the next one. Option C, this one here. You have CH3, then C, then there is another CH3, because there are two CH3s connected on this one here. Then there is a hydrogen, then this one here. There is OH, and then there is also a hydrogen, and then CH3 here. When you oxidize this one here, under oxidation, what is it going to give us? This one is going to give us CH3, CH3, then C, and then this one will go to also a ketone. You see? And again, a ketone cannot react with the alcohol, just like part A. So even this one is off. So meaning that our answer is likely to be what? D. But let's look at D. You have CH3, you have C, there are three of them on this, and then CH2OOH. Then this one, under oxidation, this is a primary alcohol, so excess acidified potassium dichromate is going to take it to carboxylic acid, because first you will get an aldehyde, and then which continues, further oxidation takes place, and then we have a carboxylic what? Acid. Now this is your Y, this is your X. Now when Y reacts with an X, this is a carboxylic acid, can react with an alcohol, right? So I will have CH3, 3 here, then C, and then COOH, COOH. So when I bring this alcohol here, and I have OH here, then CH2, then there is C, and then CH3 is here. You are going to have the alcohol loses the hydrogen, and then the carboxylic acid loses the OH. So water is given off its secondization reaction, and then we form an ester. So this is CH3, then 3 here, then C, and then C. This is the carbonyl, and then the O here, and then CH2, then C, and then CH3, 3. So what is the MR? This will be our Z. What is the MR of this one here? How many carbons? These are 3, 4, 5, 6, 7, then plus 3. That will be 10, not so? So 10 times 12. Then hydrogens, how many? These will be 9. Then 10, 11. Then again plus 9. Isn't that 20? That is 20. Then times 1. And then oxygen, there are 2. Each of them, the AR is 16. So this is 120, then plus 20, that is 140, then plus 32. This one will give us 172. So you see the molecular formula of compound Z has to be 172. So our answer is what? D. Question 34. Butanedione is a yellow liquid. So dione, that is CH3, then C, we have a carbonyl here, and then there is another one also here, and then a CH3 here. It's a yellow liquid. How does butanedione react with 2,4-dinitrophenylhydrazine and Fehring's reagent? So the fact that this one has gotten a carbonyl, okay, here and here, then it is going to give a positive test with 2,4-dinitrophenylhydrazine. That means I will look at this and this. And then Fehring's solution, this one can only oxidize aldehydes, okay? And this one is a ketone, so it can't oxidize it. That means here we shall have a negative. You see that? So we shall have a negative, which is here, but not a positive. So that means our answer is B. Question 35. Which substance reacts with ethanoic acid to give the organic product with the highest relative molecular mass? If you get ethanoic acid and you react it with lithium aluminium tetrahydride, this one is a reducing agent. So we represent it with a hydrogen here in these brackets. Then we shall get first an aldehyde, and then we get an alcohol, okay, the primary alcohol. So we shall get CH3, CH2, OH. Its MR here is going to be equal to, there are 2 carbons here, so 2 times 12, that will be 24. Then hydrogens are 6, so 6 times 1, that will be a 6. So that is 30 in total, then plus the oxygen, which is 16, that will be 46. Then we go to this one here. If this one reacts with magnesium, we are going to get magnesium acetate or ethanoate. So we shall have CH3 here, COO. First of all, this is the salt that comes from the acid, and then magnesium. We know that it forms the ion. This is Mg2 plus. Now to balance this 2 plus, I need 2 of these negatives, right? So we shall write Mg here, but then we put this as 2, like that. Then plus, when an acid reacts with a metal, we get a salt and hydrogen as a gas off. Okay, so meaning here I will put a 2 to balance that. Now let's find the MR of this one here. So the MR is going to be carbons. How many are they? These are 2, then times 2. Those are 4. 4 times 12, that will be 48. Then plus oxygens. How many are they? These are 2 times the 2, that is 4. So 4 times 16, you'll get 64. And then plus what else? We have hydrogens. There are 3 here, but then times 2, that will be 6. And then next, magnesium, its AR is 24.3. That means in total, this one has what? 48, then plus 64, plus 6, then plus 24.3. This one is 142.3. 142.3. How about potassium carbonate? So when I have CH3COOH, then plus the potassium carbonate, this one will give you a salt, that is CH3COOK. You see? Then plus carbon dioxide plus water. Now, of course, we need a 2 here. Okay. We need a 2 there. Then what else? That means even here you will need a 2. Oxygens are how many? 3. Then plus the 4, that will be 7. So these are 4, then 6, 7. So that is that. Then, but we shall look at the MR of this. You don't multiply it by 2 with this one here. This is just a number that balances the equation. Okay. So here, when we look at this, these ones are already 2. Okay. Those ones are already 2 ethanoate ions in here. But this one, it is just 1. You see that? So there is no way this one can be bigger than this. So I don't need to even waste time there. Okay. And so that means this one will be off. This one is off. They are small. And then propan 2O. You are getting CH3COOH. Then plus CH3C, then OH, and then there is an H here, then CH3. So this is esterification. We shall get CH3COO. Then this carbon here is the one now that is connected to this C, but then it has 2 CH3s connected to it. Okay, and that will be that. So let's find the MR here. Of course, we shall also have water here. Now let's find the MR, because here this one loses the OH, and then the alcohol loses the what? The hydrogen. That is how the water gets off. Then we are going to have the MR here. Let us look at the carbon atoms. 1, 2, 3, then 4, 5. Okay, those are 4, 5. So 5 times 12, you get 60. Then plus, how many hydrogens do we see? 3. And then the 6, those will be 9. So plus 9. And then plus oxygens, 16 times 2. 16 times 2, what do we get? We shall get 32. So this is 92, not so? And then plus 9, isn't that 101? Something like that. So which one is bigger? Is for this one here. So that is B here. Question 36. A sample of propyl ethanoate is hydrolyzed by heating under reflux with aqueous sodium hydroxide. The two organic products of the hydrolysis are separated, purified, and weighed. Out of the total mass of the products obtained, what is the percentage by mass of each product? Now, you are having propyl ethanoate, so that means the carboxylic acid it is coming from is ethanoic acid, and then the alcohol is propanol. It can be propan 1O, it can be propan 2O. So we have CH2, CH2. Let me use propan 1O. Okay, CH3. Then we hydrolyze using what? Sodium hydroxide in aqueous. So we are going to have CH3, COO. First of all, you would have had this one here, okay? And an alcohol here, CH3, CH2, CH2OH. So we would have had this alcohol here if we had hydrolyzed using amino acid, okay? We would get this acid and then the alcohol. But then, due to the presence of the sodium hydroxide here, it will react with that acid and you form a salt here. You see that? So, when it forms a salt here, these are the two organic products we are having, the salt here and then the alcohol. So let's find their MR. So their MR here is going to be, this is 2 times 12, that will be 24, then plus hydrogen 3, then plus oxygen, there are 2 of them, times 16, that will be 32, then sodium is 23. So what do we get here? 24 plus 3, then plus 32, then plus 23, that one is 82. Then the MR for this one here is going to be how many carbons? 1, 2, 3. That is 3 times 12, which is 36, then plus hydrogens, these are 3, then 5, and then 8. So we shall have 8 here, then plus the oxygen, 16 here. So we shall have 36 plus 8 plus 16, that is 60. So meaning the percentage by mass of this one here, sodium acetate or ethanoate, will be equal to, get its molecular mass here, divide by the total, which is 82 plus 60, then times 100. The same thing we are going to do for which one? For this other one here, for the alcohol. So I can have this one here, put off, then I bring this one here, like that, and then here I'll have this one off, and then I put the 60, okay? So what do we get here as our answer, and also here? 82 out of 82 plus 60, then times 100. The answer is 57.7%. Then this one has to be 42.3%. So that means our answer is what? C. Question 37. Which statement about PVC, that is polyvinyl chloride, is correct? Part A. The combustion products of PVC are very alkaline and harmful to breathe in. Actually, they are not alkaline, they are acidic because there is chlorine here. We look at the monomer of chlorine, okay, monomer of PVC, pardon me there, this one is chloroethene, which is like this. We have a hydrogen, maybe a chlorine here, then a hydrogen, just one of the hydrogens connected to one of the carbons into double bonds is replaced by the chlorine, And then they are saying the empirical formula of PVC is the same as the empirical formula for the monomer. Remember, empirical formula shows the simplest whole number ratio of the number of atoms of each element present in a molecule. Now, for PVC, this is an additional polymerization. So this one will open up here and then also opens up there. Then you have C, then a single bond to this. Then you have a hydrogen. Then there is this one which is created here. And then there is also another one created this side. And then here we shall have a hydrogen and then a chlorine. So as a polymer, then I will represent it with this. So this is its repeat unit. And remember, since we are looking at the simplest whole number ratio, we have very many of these. So times n, I don't know how many they are going to be, okay? But the empirical formula is going to be the same because this one here is already simplified. You have C2, then H3Cl, okay? Even here, you have C2H3Cl times n. It can be 100, it can be what? But again, to simplify it, we shall divide through by that n off. You see that? So implying that the empirical formula is going to be the same. That means the answer is B here. But see, they are saying molecules of PVC are unsaturated. They are saturated. All through the carbon atoms have single bonds, right? Then the repeat unit of PVC, here they are saying what? Is this one here. So C, H, then H here, then there is a double bond. It is a dichloroethene. No. So that one is very wrong. It is a monochloro, okay, ethene. So that is why our answer is B. Question 38. Compound Q reacts separately with hydrogen cyanide and sodium hydroborate under suitable conditions. Both reactions produce an organic product with a chiral center. What is compound Q? Now, butanol here, I'm going to first look at this, CH3, then C, then the double bond to R, and then we have a CH2, and then a CH3. When this one here reacts with hydrogen cyanide, okay, we get a hydroxynitrile. When these carbonyl compounds react with hydrogen cyanide, we get hydroxynitrile. So this is CH3. Then here we shall have an OH and then CN here, then CH2, CH3. This one is a chiral center here. Why? Because this is a group that is different from this, different from this, different from that. So that is a chiral center. So that's a tick. Then we go to another one. We put sodium hydroborate. This is CH3. Then you're going to reduce this to secondary alcohol. So this one will represent it with that symbol, the reducing reagent. So we have CH3, then C, and then you will have an OH. Then there will be hydrogen, and then CH2, CH3. So you can still see this is a hydrogen, this is a methyl, this is an ethyl, this is an OH. All of them are different. So that means there is also a chiral center here. So that means butanol actually gives us the answer. I don't need to even continue with anything here. But look at butanol. Butanol has this one here. There are two methyl groups here which are connected to what? To this carbon here. That one automatically means that when you treat with this one here, there's hydrogen cyanide, you will come up with the OH here, then the cyanide here, and then there is another CH3. So you see these two groups, this carbon here then is not a chiral center. You see? Then propanol. Propanol, you have this one here, CH2, then CHO. When you put hydrogen cyanide, you are going to get CH3, CH2, C, then there will be an OH, there will be a cyanide, but there is an H also here. You see? Is this one having a chiral center? Yes. because this one is different from this, different from this, different from that. What else do we have? When you reduce this one here, you are going to get CH3, CH2, then CH2OH. You get a primary alcohol. Now, there is no chiral center here, you see? So that is how that one also fails. The same thing I'm going to do with this one here. You'll get a primary alcohol. So for primary alcohol, then we don't have a chiral center for that case. You see? Because you will have CH3, CH2, OH. There is no chiral center. So that is that. Then question 39, compound X has the following properties. When 0.20 mole of X undergoes complete combustion, 14.4 decimeters cubed of carbon dioxide is produced, measured under room conditions. X reacts with a 2,4-dinitrophenylhydrazine. That means it must be a carbonyl compound, okay, to give an orange precipitate. So that must be a carbonyl compound. Are we there? When we look through the options, this one is an alcohol, so take it off. This is carbonyl, 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 okay? Then next, X does not give a yellow precipitate with alkaline iodine. Now, substances which give a precipitate with alkaline iodine, they must be having CH3, then C-ol, okay? First of all, they give a positive result with this one here. So let us look at ketones. Ketones here, analdehyde, that gives a positive test with alkali iodine is only ethanol because it has this group here. So that group has to be present, okay? Because this one will be, the hydrogens will be replaced with iodine, and then hydrolysis takes place. This one we cut it off, then here we get a carboxylate, okay? So here has to be an array. Now, that means we don't have this group here because they are giving what? They don't give the yellow precipitate with this. So this group is not going to be there. Now let's check. Hexane 3-on. This is CH3, CH2, C. Then you put this one here. Then CH2, CH2. How many carbons are there? 1, 2, 3, 4, 5. So we are remaining with a CH3 here. This one is not going to give a yellow precipitate. Yes, okay. Why? Because it doesn't have the CH3 connected to the carbonyl. You get it? So that one is okay. And it will give a positive test with the 2,4-dinitrophenylhydrazine. Now let's look at the other information. So this one here, when it is completely combusted, so plus oxygen here, we shall get carbon dioxide and what? And water. You see that? So carbon dioxide and water. Now, since these are 6 carbons, then I'll put a 6 here. And then hydrogens, how many? These are 5. These are 5. That is 10. Then what? 12. So we shall have 12. That means I will put a 6 here. And then oxygens, how many? These are 6 plus the 12. That will be 18. So since I have 1 here, then I will need 17 here. So I'll get 17. I will divide it by 2. Because remember here, you'll have 17 divided by 2. Then times the 2 that is here. So you will remain with a 17. You get that? Okay. Now, 1 mole of this compound, when completely combusted, gives us 6 moles of the carbon dioxide. Now, how about the 0.2? So let's look at moles of, let me actually just look at the volume of carbon dioxide produced here. Remember, 1 mole of a gas at room conditions, okay, occupies 24 liters. So how about the 0.2? Now, 1 mole gives 6 moles. That means if we want to find a volume of carbon dioxide that is produced at room conditions, we shall have this 6 here, then times the 24 decimeters cubed. Are we there? But now there is also this 0.2. So they didn't burn 1 mole, but they burnt what? 0.2. So that means I would say this will be 0.2, then times because 0.2 moles here will give rise to 0.2 times times 6. For 1 mole, it gives 6. Then 0.2 will give what? Will give the 0.2 times the 6. Okay? If you want, you say divide by 1. As simple as that. Okay? Then after that, we multiply by volume of a gas under room conditions, which is what? 24. So what do we get here? 0.2 times 6 times 24. This one gives us 28.8. So this one is off. Okay? Then we go to propanol. Propanol is CH3, then CH2, then CHO. You also add oxygen, and then you get carbon dioxide, and then what? Water. Then these are 3 carbons. So for 3 carbons, I will put a 3 here. And then hydrogens, these are 5, then 6. That means I will put a 3 here. And then oxygens, these are 3, then plus the 6 there. 3 plus 6, you get 9, not so? That means here I will need 8, and then plus the 1 here. Now, do you realize that the moles that we have here, the moles here, 6, but then here we are having 3. So it's just a half of this. So that means my volume of carbon dioxide is just going to be a half of this, which is 14.4. But we can say 0.2, then times the 3 moles we have gotten for carbon dioxide, then times the 24. The 3 we are having here is a half of the 6. So just multiply this one by a half. You get the answer as 14.4. And this is actually the answer because we have gotten what we are looking for. Okay? Already this one is on. Propanone, and propanol. Let's see. Propanone is CH3, then I put a double bond on this, and then CH3, which is like this one here. But propanone has gotten this group here. That means it is going to give a positive test with what? Alkaline iodine. You see that? This one here, also when we burn, it is going to give us the same equation as this. It gives us the same volume. But when treated with alkaline iodine, for which it is going to give a positive test. So that is why this one is off. You see that? Question 40. A sample of butyrenoic acid, this one here, is analyzed using the infrared spectroscopy. And they are saying the infrared spectrum shows a broad peak in the range 25 to 3000 per centimeter. So look for it. It is here. So they are saying which bond is responsible for this peak. Just come here. The bond is the OH. So that is the OH here. And that is the answer. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.